2 is mathematical modeling. It's a short chapter. We're only covering 2 sections. So starting in 2.1, we're going to cover linear functions. So we're going to learn how to analyze graphs in the context to real-world applications, use the correct linear model, and apply linear models. So I'm going to start off teaching you the recursive and explicit formulas for a linear function. And the recursive, I think, this is my theory anyway, that it's helpful in understanding how you build a linear function. So it's like starting with the building blocks. Usually when you're presented with linear functions, your professor or teacher says slope and y-intercept. But learning the recursive will help you understand where those things are coming from. So we're going to use an example. You're saving up for tickets to see your favorite artist in concert. Maybe you're a Swiftie, I don't know. And you currently have $24 that you can put towards the tickets. You establish a weekly budget to help you toward your goal and decide to put $5 a week aside to go towards the purchase of the tickets. The concert is 8 months away and your ticket costs $180. How much money will you have in 4 weeks, 16 weeks, and 24 weeks? Will you have enough to purchase the tickets in 8 months? So this approach to linear applications may seem foreign, but bear with me. It's actually a really good way to see how to build a linear function and understand all its moving parts, which I just said. So a lot of things in the real world are represented with linear and exponential functions like population, sales, stuff like that. So hopefully you find this useful. All right, so back to our saving up for concert tickets. We're gonna let P sub n represent the amount of money in dollars after n weeks. So this is called subscript notation. And we've seen it a little bit already. I brought it up when I gave the definition, the definition for weighted average, it came up. So it's just a way of keeping track of things. Because if you didn't have symbols, then you'd have to write it out in words. But that's exactly what we're going to do. We're going to write it out in words. We're going to write what each one of these mean. So if P is the amount of money after n weeks, then P sub 0 means that n is 0 and P is the amount after 0 weeks. That's what it breaks down to. So for P sub 0, that's always the initial amount, initial or starting amount. So you generally know what you're starting with and then you build from there. So in this case, it's the initial or starting amount that you have saved for the concert tickets. Which is $24. Okay, I think I'm going to go ahead and erase this. So that's what you want to put in your notes. And then P sub 1 would be the amount of money after 1 week. P sub 2 would be the amount of money after 2 weeks. And then P sub 20 is the amount of money after 20 weeks. So hopefully this subscript stuff is starting to make sense. If we didn't use it, then we'd have to write this sentence out every time we wanted to talk about it. So using the symbols and the subscripts gives us a way to refer and talk about things in a very shorthand manner. So now the calculations, which don't actually match up with this. It's 4 weeks, 16 weeks, 24 weeks. That's okay. We're going to calculate what I have here. All right, so P sub 0, there's no calculation. That is generally given to you. It's $24. So P sub 1, that's after 1 week of saving. So it's going to be $24 plus. Let's go back and see how much are we getting a week, because it's the amount of money per week. You're putting $5 a week aside. So that means in 1 week you'll have 24 plus $5, which is $29. After 2 weeks, you're going to have that $29 plus another $5. So note that that 29 gets repeated here, which is $34. And then after 3 weeks, it's $34 plus another $5, which is $39. And then in 4 weeks, it's $39 plus $5, which is $44. So this is why it's called recursive, because you're recursively using the previous amount. So it's building on the previous amount, and that's what makes it recursive. So the recursive formula is P sub n is equal to P to the n minus 1, so the previous amount, plus D. So this is the previous amount. And D is called the common difference. That's how much it's changing. And in our example, it's changing by $5. So the common difference is $5. 18 months is 4 times, oh, I have a mistake there. Is it 8 or 18? 8 months away. Yeah, this should be 8 months. Sorry about that. Is 4 times 8, which is 32 weeks. Using the recursive formula, it would take a while to do that because we'd have to keep doing it until we get to P sub 32. Is there a better way? Yes. That's when we use the explicit formula. And in most cases, you want to use the explicit formula. The recursive one is just helpful for understanding how you build a linear function. So the explicit is P sub 0 plus n times D. Or you could write it as n times D plus P sub 0. It doesn't matter if you switch those around. So P sub 0 again is the initial amount. D is the common difference. In this case 5. And then n is the number of weeks. So if we have the number of weeks, then we can just plug that in, and we're using 32 here. So you set up your explicit formula. So it'd be P sub n is equal to $24 plus n times 5. And we're using 32 for n. So we plug that in and calculate that out, and it's $184. So after 32 weeks or 8 months, I would have $184 saved. And since the tickets are only $180, I will have enough to pay for them. So, by the way, if you wanted to answer the questions that were actually here, the 16-week and the 24-week we didn't do, you would probably want to use the explicit formula. So I would do P sub 16 is equal to 5 times 16 plus 24. So that's $104. I'll double check that, but I'm pretty sure my arithmetic is right. Yep. And then the piece of 24 plug in 24 times 5 plus 24, it's $144. So that would be much easier than using the recursive. The recursive was fine for doing 1 or 2 weeks, right? But if you need to go further out, it becomes pretty tedious.